So I'm very happy to announce our next guest for the podcast episode. It's a pre-conference podcast episodes for the conference scheduled in fall in October. It's a green NRMM forum which will be held virtually. We have here Carraro Group's e-power systems director Giacomo Fiocchi. I'm very happy to introduce him as our honorable speaker. And I would like to give a word to Giacomo. Giacomo, please tell us about your experience. Tell us a little bit about what you will be speaking about. Tell us about Carraro Group and what should we anticipate at the conference.
Yeah, thank you very much. It's a pleasure to be here with you. So I joined Carraro some years ago for a new deal focused on electronic and electrification. This is the reason why we started with these new units called e-power system, where this blue E in front of the name means exactly electronic, electrified system. So it's an opportunity for the company to enlarge the scope in terms of product, in trying to integrate all this new technology into mature product like transmission and axle, but also into vehicles. So the mission of my units is to help our customer to design their own electrified system. We can support the current business of Carraro, integrating electric motor, power electronic, and so on into our current products, but we also support the customer with engineering services, trying to customize the right product for them. So one size doesn't fit at all in the electrification world. This is the reason why we are really focused on tailor-made products, completely designed according to the specific needs of our customers. So we start from the scratch. We can offer obviously off-the-shelf product, but we can also offer a customized product like e-motors and e-drives for our off-road application. I come from an hybrid experience, so I both experience on and off highway together. I see a lot of synergy trying to exchange knowledge from both the world, the automotive world, and the off-highway segments. I work in the Motor Valley with Lamborghini and Ferrari, but I also work with Eco Group. So today I combine my experience of automotive and off-road vehicles together. And I see this as an opportunity to offer at the end a really integrated and consistent solution to our customer. That's more or less my background that today I'm sharing with the Carraro Group in order to enlarge, as already said, all of our products and services to this new technology like electrification.
And Giacomo, if I understand correctly, Carraro Group has its own product line of manufacturing, if I'm not mistaken, right?
Yes, absolutely. We are enlarging the product portfolio. So today we have the mechanical and hydraulic and electronic transmission and axle. And now we are also offering electrified axle transmission. And also we are focused on off-the-shelf product or single product like e-motors and power electronics. We offer services, so also software. So we design and develop software customized for our customer, able to be integrated in our own controller. We have our own controller, also able to be integrated in the customer controller if it's needed.
In your own control. That's exactly what I wanted to double check, because your, let's say, experience and your, I would say, presentation will come from, it's not a pure, let's say, purely a vendor-driven experience. This is something that you have been developing in-house within your own product, right?
100% in-house. Yeah, you are right. 100% in-house. Yeah. And also my presentation at this fair is focused on a real experience that we are offering today to our customers. So we will drive all the attendees of our presentation to our process. So how do we electrify a project starting from the scratch? So which are our guideline, the process that lead us to electrification. And then we will finish with a real example offering the electrification of a compact wheel loader based on two different solutions in terms of voltage level and components, and try to identify which are the pros and the cons of both solutions.
Okay, okay, perfect. Look, it definitely sounds very interesting. If you don't mind, let's go through a couple of questions that definitely would be relevant and interesting for our audience to hear about. Uh, First, if we can talk a little bit, let's make the notion of this podcast is, as we mentioned, is to create or to level up the awareness about the presentation. But we definitely need to discuss a little bit of what is the current situation, current trends on the market, and what you will be presenting about. So a little bit more into detail. So can you tell us a little bit? What are the market trends for the electrification in the off highway right now, currently?
It's a good question, and unfortunately, I don't have the crystal ball, so I'm trying just to share which are the feedback coming from the markets. We have one of our eye looking at the automotive, because automotive is driving the change to electrification. So what's happening in the automotive will anyway will be derived and will impact what is happening in the off-road. I think that the electrification is becoming a mature technology, and the volume in the automotive is growing year by year. We are looking at a similar reaction in the off-highway market at the moment. If we compare the two main sectors that are agriculture and construction equipment, today, let me say, construction equipment is more advanced and focus on electrified vehicle. For some reason, first of all, the regulation are leading and pushing the company to electrify. If you want to work in a city center that is a zero emission zone, there's no chance, you need to electrify. And also duty cycle of construction equipment machine fits very well with the electrification. For example, there is the opportunity to regenerate in some operation, offering a regenerative cycle. For the tractor, also tractors are looking at this opportunity. At the moment, they are trying to understand which is the right benefits coming from the electrification of a tractor. Maybe it could be more interesting, the hybrid solution, in order to support some electric implement, or to improve the efficiency of the traction of the tractor. But let me say, at the moment, construction is leading the market in the electrification. The expectation is to be able to reach 5% in terms of electrified vehicles in the global markets by 2025, 2030. In between these 5 years, we will reach at least 5%, maybe 10% at 2030. Hard to say at the moment. What we are expecting is a significant growth at a certain point. We don't know exactly when, but we need to be prepared, because we are sure that it will happen.
Okay, yeah, definitely interesting podcast. Sorry, I have to stop for here for a second. Definitely a very interesting projection in the forecast. Giacomo, what is the most suitable? I mean, we're speaking right now about your presentation is more tailored for the construction, right? But
yeah,
when we're speaking about agro or construction, I mean, basically anything when we're speaking with off highway, I know it's a very broad question, but what would be the most suitable applications here?
At the moment, we are working on both sides, on agriculture and construction. For sure, we are starting from the small and compact machine. It's more than 20 years that Carraro supply, produce, and design electric axle for material handling. So material handling, it's already a mature market for electric. Now we are focused on small and compact machine. For example, in the construction equipment, all the small and compact wheel loader from 3 tons till 7 tons, 8 tons. Teleboom handler, small and medium machine till 11, 12 tons. And also on the agriculture, we are really focused on small and compact tractors, so something like under 120 HP in terms of power. All these applications are suitable due to the size of the vehicle. considering that we have to ensure a good autonomy of the vehicle, so we have to install the right battery pack according to the needs of each vehicle, and also the mission that this vehicle has to accomplish is suitable for an electric, hybrid, or full electric, or also mild hybrid architecture. As soon as we are increasing the size of the vehicle, it's becoming a challenge. Today, there are some static machine with a big size in the construction that works with the diesel engine as a generator, so another approach. Today, I think that the real challenge is for the big tractor with more than 200 HP. In terms of autonomy and in terms of duty cycle, the electrification of this machine at the moment is a real challenge. Maybe we have to be more focused on the electrification of the implement and not on the complete tractor.
Okay, and the technical solutions here, I mean, we have mild hybrid, we have PHEV, we have FEV. What would you say about that?
It's impossible to say there is the best-in-class solution. Every solution fits with the needs of each machine. This is our mantra at the moment. So every time that we approach a new project, we want to start from the data of the vehicle, from the real duty cycle, and then we have to identify the right architecture for each specific machine. The mild hybrid, it's an opportunity, for example, to lead the downsize of the combustion engine in order to reduce the cost of the engine and also the fuel. For example, in the stage 5 regulation, it's needed for power greater than 55 kilowatt, the introduction of a complex after treatment. We are avoiding, for example, this introduction of the SCR, downsizing the engine and compensating through an electric motor. There are other machines that fits very well with plug-in hybrid, for example, because they need also to work in full electric for some transient phases in order to be zero emission for some greenhouse operation, for example, and trying also to increase the efficiency of the entire system. There are opportunities for full electric of some vehicles where the autonomy is limited, where the size is limited, and where they have to be zero emission completely for 100% of the duty cycle. Every time we need to understand better the duty cycle of the machine, the size, the available space, and then we can identify the proper architecture.
Can we take a little step back here? Yeah. Can we speak a little, let's say, on a general topic of the benefits of electrification? There are definitely lots of challenges here, but can we speak a bit about the benefits of the electrification? Not for the planet and not for our society as the end users. We all know that, and hopefully by 2050, Europe will be the first continent who will be definitely the emission neutral. However, speaking about from the perspective of the industry,
of the user, for sure, the health and the emission reduction is the first point that is driving the technology. But from an end of user point of view, I think one of the advantages is the efficiency of the entire system. Through the electrification, we can increase the efficiency of the system because the efficiency of the electric devices like motor and power electronic, it's more than 95%. So it's impossible today to reach this such of efficiency with hydraulic and diesel solution. This is the first benefit. Just to give you a number, on our mild hybrid powertrain, we through a small electric motor combining with the downsize of the engine, we increase the efficiency of the entire system of 3%. The second point is the controllability and the precision of the vehicle. Through the electric motor, we can modulate absolutely the engine speed, because if we are coupling the diesel engine through an electric motor, also in a P0, P1 architecture, we can modulate the behavior of the vehicle through the electric motor, avoiding to have an unstable vehicle speed, and in order to be more precise. With a full electric, for example, we can 100% electronic control the entire traction of the tractor. So this is a solution that also fits very well with an autonomous vehicle. And also the real advantage is to have an electronic control of the traction from the ground. If we think at the most complex solution, that is the P5, so the electric wheel, through the electrification of each single wheel, we have a complete torque vectoring of the vehicle. we have the integrated differential and four-wheel drive. There are some other advantages. For example, as soon as we are using electric devices to be connected from the vehicle, we can offer the electric source for any device. That could be an implement in agriculture or any electric device in a construction equipment area where maybe the electric source is not available from the grid. I think that for this machine, it's absolutely an interesting opportunity to be able to connect any electric device to the vehicle that becomes a real electric source. These are some of the main advantages that at the moment we can highlight and see into our application. If we are looking to just to close the loop, if we are looking at just cost saving, at the moment is not true. And really fair and transparent, so the technology is not self-sufficient from an economic point of view if we talk about full electric. The cost of a battery at the moment is too high. We are expecting that the cost will decrease from the automotive market in order to ensure that also through the fuel saving, we can also compensate the cost increase of a full electric vehicle compared to the current version.
Giacomo, first of all, thank you for such an unfolded answer. When we're speaking from the perspective of the Carraro group, I will take a little, okay, I'll ask this question next. First, can we speak about the challenges then? Firstly, what challenges do we have and constraints with this process?
So the first challenge is a mentality approach. We have to lead our customer, our end user, trying to rethink about the vehicle behavior and the vehicle functionality once that the electrified system is integrated. So we cannot just copy and paste the diesel current version with the new electric version that fits exactly 100%. If we are installing a battery, maybe the size is not big enough to compensate the entire autonomy of the current diesel vehicle. And also we have a really expensive and heavy battery to compare the current electric vehicle with the current diesel one. There's a cost challenge at the moment, and this is really important if we look at the automotive. This is the reason why we are looking at the automotive. We strongly believe that the mass adoption coming from the automotive will help us to reduce the price of components, and battery at the moment is leading. The technology, as already said, for a full electric vehicle is not self-sufficient. If we also have a fuel saving of 50%, maybe we are not able to compensate the extra cost of an electric powertrain for a full electric vehicle with 7 tons of full operative weight, something like that. If we look at some small hybrid architecture like P0, today we are already able to reach the complete economic sustainability in the entire life of the vehicle because we are downsizing the combustion engine. We are installing a small battery and a small motor. So I think that the challenges are the cost and also the energy density. We have to make an improvement. We have to make a step forward in the energy density of the battery. So in the same space, we have to increase the quantity of energy. The gap between the fuel at the moment and the hydraulic is too high. So in the same space, we are not able to integrate enough energy. And this is one of the challenges because we are electrifying more or less vehicles that already exist, and we are not able to completely redesign the architecture of the vehicle. So we have to find the space to integrate the battery, able to sustain the entire mission of the vehicle. So the autonomy could be another challenge that we will face.
Look, speaking from the perspective of Carraro Group, right? And correct me if I'm wrong. You produce the tractors, right? You do have.
We also produce tractor, specialty tractor for vineyard and orchard. Yeah.
Exactly, the orchard tractors. So when we speak about for example, the orchard tractors, let's say how, speaking from the manufacturer's point of view, right? How seamless would the process be when the manufacturer decides to electrify one line of their production? How seamless this process can be, or how, let's say, complicated it can be from the manufacturer's point of view. If you
yeah, this is one of our challenge because we have a tractor factory into our group, so we design and produce. We assemble the complete tractor. So There's a process challenge as soon as we are electrifying a tractor, because we have to find people that are skilled and trained to deal with electric devices in the process assembly, but not only in the process assembly, also in the after sales or service and so on. Especially if we are moving from low voltage to high voltage, till we are in the low voltage range, so under the 60 volt of the automotive, we don't have safety issues, so this problem is not so high. As soon as we are talking about high voltage, like 350 or 400 volts, we need trained and skilled people and right processes to deal with high voltage electrified components. Obviously, we have to take care about the new asset that we need into the line, for example, end-of-line tooling for the testing of the entire vehicle and so on. But I think, first of all, trained people in the production line, but also in the services into the field to support customer dealing with this new technology.
If we'll put a bottom line question here, right? And you speaking as a company, you speak on behalf of a company and seeing it on the side, from the side of the manufacturer as well. To electrify or not to electrify? I mean, what would you, I mean, we definitely understand that we're lobbying the electrification, but so could we say that in order to reduce the carbon and the emissions, we should electrify? Is this the one key suit for all the problem? Can we state that, or it's more complicated than that, and we should be looking also at the alternative fuels, renewable diesel, and so on and so forth? Or do you think that with the challenges and with the huge pluses that we mentioned, should we electrify? I mean, should it be the answer, the key to all, like electrify, or it's a little bit more complicated than that?
I think it's one of the answers to solve this problem. So we are not electrifying just to like the technology. Electrification and technology are enabler to support our fight against the reduction of CO2. I'm not expecting that electrification will be the only answer. So I'm expecting that we will have a heterogeneous solution for any application. So we will have some technology that will be more suitable for some vehicles, other technology more suitable for other vehicles. I don't know, hydrogen or fuel cell seems to be really good solution for trucks, heavy trucks, machine. Electrification is absolutely good for small and compact machine. Alternative fuel could be another option. So I'm not expecting that we will have just electrified vehicles. I'm sure that electrification will be a key player in the next 10 years in order to fight against the CO2 reduction. Okay,
Giacomo, thank you very much. There is a lot of interesting technical and specific discussions we are anticipating, and our forums are extremely networking oriented. So I would expect a lot of questions and answers session to be, quite active. So we're looking forward for your presentation. Thank you very much for joining us on this podcast, and looking forward for October. And before that, we'll be gathering all the let's say questions, comments made to us according to this podcast, and we'll just pour them on you during the presentation.
Okay, so thank you very much for the opportunity, and see you on October.
Thank you very much.